Hello, my name is Mike Virgilio, and I'm a senior security consultant with AWS ProServe. I work with clients to evaluate and improve the security posture of their AWS environment, as well as application workloads contained in these environments. Today, I'm going to show a demo on how to identify inbound data paths from the internet to AWS environments using Network Access Analyzer. Network Access Analyzer is a feature which analyzes resources within an environment and allows you to validate if paths exist between specified resources and segments as defined within a Network Access Analyzer scope. I'm going to start the script to give it some time to process my demo environment and then continue to explain what's occurring. The solution has already been deployed in this lab environment, but installation instructions are included in the GitHub repo. As we've worked with clients, we've seen the need to locate and verify all inbound data paths originating from the internet and terminating on resources within your environment. Solving this is a very tedious and complex task, as there are many individual networking components which need to be reviewed to determine if these paths exist. These inbound paths are typically configured within the environment for workloads which are internet-facing, and so these types of paths are expected to exist. In many environments, however, network controls may be flexible to allow the developers the freedom to make changes as they see fit, and this may come with the creation of unauthorized inbound paths. These unauthorized inbound paths pose risk to other workloads if they are not properly configured. This solution I'm demoing has been built to solve this use case for clients by leveraging Network Access Analyzer's capability to analyze resources, bash scripting to deploy this analysis across multiple accounts at scale, and finally process all findings via Python into an easily readable format for review. While this processes, I'd like to show an example of output from an environment. The output CSV file has been opened within Excel to review the findings. While there's a lot of data in this file, I've highlighted the first two rows to review a specific finding. The data which is included in this file gives all of the metadata necessary to track down the particular resource within the environment, including the account ID, the VPC ID, subnet ID, and so on, including the security group ID and port and CIDR range that's open to the internet. Looking down the sheet, I've highlighted a couple other findings that stick out to me as potentially high-risk findings that I'd want to review as I'm going through and determining which paths are authorized or not. In order to get this output, the bash script is working through this process. In step number 1, the script was executed on the EC2 instance. It assumed a role and then checked an S3 bucket in step number 3 to see if an exception file existed. If it does, it's downloaded to the EC2 instance and used during processing. It then makes a cross-account assumption in step number 4 to the organization management account to generate a list of all AWS member accounts within the organization. Using that list, it analyzes each account in step number 5 to generate findings which are written back to the EC2 instance. Once all accounts are processed, step number 6 processes all of the findings into a CSV, and that CSV is packaged together and uploaded to the S3 bucket in step number 7. When the file is written to the S3 bucket, an SNS message is sent to the authorized user, letting them know that the report has been generated. In step number 9, the authorized user connects to the bucket, downloads the report, and can start reviewing the findings. If we switch back to the EC2 instance, we can see that the bash script has completed execution. All of the files have been processed and uploaded to an S3 bucket. Within the S3 bucket, there are two objects, NAA findings and NAA unprocessed. The findings file contains all the findings which we reviewed earlier and have been processed via a Python script. The NAA unprocessed files contain JSON output directly from Network Access Analyzer and has not been processed. This allows additional review using the native format if necessary. All of the code and deployment procedures are present on a public GitHub repo. The two main files that you'd want to start with are the README file, which give a general overview of the solution and the architecture diagrams, and the file called Network Access Analyzer Procedure.md, Markdown. This Markdown file contains a step-by-step deployment and usage instruction set, which allow you to deploy the solution, modify it for your environment, and learn more how the solution works. The URL and QR code direct you to the GitHub repository where the code and deployment procedures exist. It is critical to identify data flows within AWS environments as part of a strong security posture. If your current security tooling doesn't offer the capability to analyze data paths, review the solution as an option to close this gap, and review Network Access Analyzer's capabilities to see which other use cases it may solve for you. Thank you.